Dear students, now we will take a look at the traceback. The importance of traceback can be understood by just looking at the Needleman-Wunsch algorithm. The purpose of Needleman-Wunsch algorithm was to dynamically program and align the sequences that were given to us. The sequences, of course, could be the DNA, RNA, or proteins. Once you have calculated the alignment matrix, there can be several diagonals that are there. There can be several alignments. Now the traceback strategy comes in at this point to help us to extract the best alignment. So let's see how this works. So in the Needleman-Wunsch algorithm, you use the top, the diagonal, and the left element to compute the current element, and in this way you computed each and every element in the matrix until you reach the bottom right. Now, using the bottom right element, that is the last element that was computed in the matrix, you can trace back to the top left. In this way, you can find the optimal alignment. But the question is, how do we trace back? So let's see how Needleman-Wunsch algorithm can help us find the optimal alignment by the traceback strategy. So working on our example, so this was the matrix that we are trying to fill, the alignment matrix in which we are trying to align two DNA sequences here, and we computed each element like that, and the entire matrix was filled up here. So the last element in the matrix that was computed came out to be 33. So in this way, we have an option now to trace back till this position to compute the best alignment. By trace back, I mean to shift step by step such that we reach the top left. But how do we shift? Because there are so many options that are here, as you can see by these red lines. This can be another strategy, or this can be another strategy to move from this position to this position. So which traceback strategy do you choose? Do you choose 1? Do you choose 2? Do you choose 3? Do you choose 4? So here I will guide you how to select the traceback. So starting from 33, that was here, you select which position, the top, the diagonal, or the left contributed towards calculating 33. C would have matched with a C, and the match was plus 10. So 23 plus 10 would give you 33. So we take this traceback. Next, this G does not match with an A here. So the mismatch is minus 2. So 13 minus 2 would have been 11. And here 28 minus 5 was 23. And here 8 minus 5 would have been 3. So this is the position which was the maximum, and therefore we will connect it like that in the traceback. Next, so this C matches with this C. So the diagonal plus 10 is 18, and these, the top and the left positions, did not give you this score. So 18 came from this 8, and therefore this traceback is selected as well. Next, C does not match with a T, and therefore it's a minus 2. So 10 minus 2 will be 8. And here 13 minus 5 will also be 8. So here both of these elements, they result in an equal value. So you have two options here. either to select this one or this one. So let's say we select both of them. And we continue this process until we reach 0. So now let's see how our traceback is looking at the moment. As you can see, we're heading towards 0 and we have managed to reach by 2 paths. The first one is like that, and the second one, which was similar till here, but it got another contribution that was equal. So this is another traceback route. So using these two strategies, you can arrive at an optimal traceback. And once we have the traceback, we'll see how to compute the alignment. So in conclusion, after completely calculating the alignment matrix and scoring each position, you can have a traceback. The traceback helps you to identify the optimal alignment, and there can be multiple tracebacks from the bottom right to the top left positions in the matrix.